distribution. So this was a talk which was intended for philosophers, some physicists, and some neuroscientists. Of course, today we have a mix of these, and I'm just going to say stuff. There's not so much that I want to say. Really would like to hear opinions, and I mean, I'm gonna offend someone. It's just too many communities here that I can talk and make everybody happy. So please, with all my best wishes, I do not wish to offend. These are just opinions. Right. So let's start. If I can start this meeting. So this was an ontology congress on the title was Determinism and Free Will. And I thought this conference is happening for a reason. There is a block in theoretical and fundamental physics that has been preventing us from making progress. Reductionism. I don't think this is new. Just trying to put this somewhere where I can. I'm not saying anything new. I saw George Ellis. You're in the call, so you'll have lots to say as well, because you've talked about this before I did. But so if somebody in the audience was not a specialist, it could be determinism, reductionism. They're not the same thing. But if you're talking to philosophers, you have to be more careful. So my favorite philosopher of science, Paul Feyerabend, I know that he's very, very high controversial, but Paul Feyerabend has saved my career many, many times. And during difficult stages in my career, I just carry his book with me as if it was a Bible. And he said something, I'm not using quotes because I can't exactly find the quotes. It is all methodologies come with limits. There's no methodology that can be used in any field of science without limits for their application. So it is not only the laws that we derive that have regimes of validity, the methodologies we use for deriving those laws have their own limits of validity. And reductionism has served us long, and it has served us well. At the moment, but 10 years, 20 years, we are reaching territories in theoretical physicists and sort of physics where reductionism fails, and it fails resoundingly. An example is the neurosciences. I think a lot of the people here know the neuroscientific field. You probably know the big divide there is in the neurosciences between reductionists and non-reductionists, and a lot more divides than just this one. We are reaching frontiers as biologists on the foundations of how biology operates, how biological systems self-organize themselves. Reductionism fails really very, very rotundly. And of course, quantum mechanics within physics, our own fields. How many problems have been created by our insistence of applying reductionism to quantum mechanics? And if you talk to people who live in the real world, like quantum computing communities trying to build quantum computing, they can tell you that reductionism doesn't help us, and they struggle enormously to keep wave function from decohere. And unitarity. I know there's some quantum mechanics community here as well. How many problems do you think have been created in our community by the insistence of keeping unitarity? that go, it's not exactly reductionism, but it comes from there. Now, this is a part where I was going to tease Stu. If he doesn't, he's of course earning millions of dollars right now. Stu, if you're listening to the recording, this is the part when I'm teasing your book. So this is the situation. Stu Kauffman, who we all love, came to Perimeter in October 2019, I think. He gave a talk basically saying physics has ended. The theoretical physics is, you guys know. Now I am taking it from here. A world beyond physics. So we, theoretical physicists, with our languages, with our principles, with our methods, we cannot go past the boundaries of biology. Well, I've got news for you. It is not ending. Theoretical physics is not, it is not ending, it is expanding. We're developing tools that break down reductionism, and we will break the boundaries to understand more fields beyond our own limitative reductionism understanding with new tools that which are not, are however mathematical, but non-reductionist. So this is what we're doing with, it's taken it 2 years, most of all, I shall say, because Kauffman and Smolin shouted at me for the first, I should say, well, Lee emailed me maybe 2-3 weeks every day, repeatedly saying this is impossible. And Stu, it's a pity you're not here. You even shouted at me, I don't know, I don't care. And eventually they understood what I was talking about. And we've been working for 2 years on this. So there are mathematical tools to explain limited parts of biology quantifiably. And a reminder, since this was a symposium on free will, just a reminder, which I think is important if you're talking to philosophers, free will still comes from our brains. Our brains, no matter what Silicon Valley is doing, is still biology, my opinion. We're still biological organic organisms. So you can develop artificial intelligence all you want. We're still living organisms. So free will starts with biology. And this is a slide just saying the results of the BioCosmology. We can talk about these. It's later. So we have, now that I'm in this specialist audience, I can say that we've created this common language, which is, I'm going to say in the next slides, for the first time between cosmology and biology. And we have a quantitative value for how much the biosphere is worth based on foundational principles in cosmology. So based on, if you're not an expert, we've been trying to say these viewed through the lens of black holes and dark energy and dark matter. So the currency of the cosmos. Sorry. So why can physics not describe free will? Because we do not have the Lagrangian for the human brain. We don't have the Lagrangian for anything apart that's not theoretical physics. Just a second. Here's the standard model Lagrangian. Everybody in the audience have seen this, or apart from the biologists. And what's the standard model for what's the Lagrangian of the standard model for biology? And here is, let me see what's coming next. Okay, so in 2 years, I found a very simple way to explain to theoretical physicists why there is no standard model for Lagrangian. George Ellis, I know you have the papers that you've sent is something very similar. I don't think it is exactly the same, but I'm really looking forward to discuss this with you. So why do we have a standard model for particle physics? Because we've got data created, say LHC, any particle accelerator that you want. We've got a finite number of elementary particles. And imagine that you are the theoretical physicist that for the first time is writing down the Lagrangian for the standard model particle physics. You look at the data, okay, this elementary particle 1, I don't even remember how many elementary particles there exist, but they're fixed. And then you write the Lagrangian, I mean, with difficulty, and it's a huge mess that I showed previously, but it is doable, and we can derive and make predictions with the standard model of particle physics. Now, as a biologist, what happens is you look once, you've got your data on the number of elementary particles, and you start writing, somebody else, sorry, you start writing your Lagrangian. Next time you look at the data, a new elementary particle has popped up, a new quark or a new electron or muon, or a new elementary particle has popped up, and you have to go back and erase everything you're doing and start deriving the Lagrangian again, because there's new data and there's more degrees of freedom. And you write, and next time you look, another elementary particle has popped up. And that's why there is no standard model for biology, because the number of degrees of fundamental elementary particles in biology is increasing constantly, and it is increasing in unpredictable ways. And I'm going to give you an example. So 2 minutes after the universe was created, there's this strong force phase transition. And for the first time, atoms can be created. It can be a proton and neutron can create an atom. And that's a new thing at that time in the evolution of the universe. And that's we call that the new bound state. And if we had the Lagrangian at time 0 at the Big Bang, we would have been able, with some, able to predict that at minute 2 of the age of the universe, there would be a phase transition and atoms were going to be possible, and Big Bang nucleosynthesis was going to happen. The same thing is not true for biology. The existence of new bound states, like atoms or molecules or whatever it is that is created when phase transitions happen in the standard model, the same is not true in biology. And I'm going to give you an example which Stu loves, which is an example of a proton neutron creating a bound state in biology. So there's a fish. There's a fish swimming in a pond. There's a bacteria swimming by, and fish have swimming bladders. The bacteria swimming around somehow enters the swimming bladder and finds, this is a nice space for me to live in. This swimming bladder gives me selective advantage within natural selection. And the fish somehow also benefits from the bacteria inside the swimming bladder. What has happened here? The new system, swimming bladder and bacteria, are now themselves a bound state, a new degree of freedom. They are going to evolve according as a novel elementary particle, say. And who could ever have predicted that there would be a bacteria swimming by the swimming bladder? It's not, you can't predict all the possibilities for what can happen in biology. So these are the three papers. I think I said there's an embargo, but those are the principles. I'm not allowed to talk about the quantifying values of what we got, but they're coming out on the 25th of October. Yeah, 25th of October. Let me just see if I can. And George Ellis, if you're listening, this is the part where I think it is different. So how are we counting microstates in biology? We are using this tool that apparently is very common in economics or patents, development of ideas, combinatorial innovation. And so Stu calls it the theory of the adjacent possible. And basically the idea is that at any moment in the evolution of organic system, the number of possibilities is for what's going to happen next is ever growing. Whereas in physics, we have finite configuration space, or I mean large but finite. Hilbert spaces are finite. In biology, you cannot write down all the possibilities. Who would have thought that the bacteria would be swimming by the bladder? So I've been a bit naughty here. We've computed the Hilbert spaces, the biosphere. It's not quantum, it's just configuration. And because I only have a little computer, we had to stop at the first RNA molecule because the computer couldn't do anymore. And so at redshift 0.4 in cosmology, using Planck satellites, since we've got cosmologists here, we've computed what's the size of this number. And I can come back to that. Like I said, the actual results are under embargoed, but we are discussing here free will. And so I want to go to that. So I'm just a theoretical physics and a cosmologist. I am asked routinely for interviews on consciousness, on free will, on traveling. It was when we're going to travel, live in other planets. And I would just like to say, why are theoretical physicists asked to talk about consciousness? Or we don't know. I know why we are. And again, oh no, sorry. The quantum mechanics. So there are many large groups of physicists and philosophers thinking that somehow quantum mechanics has a role to play in free will. I have not heard one piece of evidence for a statistically significant correlation between quantum mechanics and free will. And I mean, statistically significant, we're talking about, 95% confidence level. It's basic stuff. At the LHC, they talk about 5 sigma, which is like 1 in 2 million. So even if we're neuroscientists or philosophers or quantum mechanics physicists, we're scientists, and so we need data. And if we try to correlate what happens in the brain regarding quantum mechanics, let's use data to do that. Now, this is really the reason why I'm giving this the talk. Georg Northoff. He's, for me, the person whom Lee and I and Georg have been collaborating, and we're going to collaborate now. But it really, in what regards sciences of the brain, for me, is the ultimate knowledge. And I don't know if Felipe is here. He's got a collaborator in Portugal, and Georg's going to visit soon. And why is Georg so important? Because he takes three worlds together. He's a philosopher, he's a neuroscientist, and he's a psychiatrist. So when he talks about the philosophy, oh, Daniel Bennet has just entered. Daniel, I am talking about Georg Northoff and saying why it is important that philosophers of the mind, philosophers of free will, cross more than one field. And my star, like I was saying, Georg for me is the world's specialist on matters of the mind. Number one, Georg doesn't mention consciousness, which my own students that I have seen here attending are also know. We do not mention the word consciousness because it's like the popular culture. Everybody talks about consciousness. Nobody knows what it is. So let's keep our feet on the ground. And Georg, the reason why he's so, for me, has such an organic view of the human brain and all brains is because he's a psychiatrist. So he has clinical data to back up the statements that he makes. In particular, this is something that I would like to advocate. This is Georg's sentence. In the human species, we need to de-anthropocentricize, whatever that word, how can I say that word, the human brain. The human brain is just a brain, like other animals have brains. And Georg has said this sentence that to me, I told him, this is the most beautiful idea I have heard for the whole of the past decade. In the animal world, there is not a line dividing animals with consciousness from those without consciousness. It is a continuous spectrum. I find this absolutely beautiful and so refreshing in the world of the neurosciences, where you hear a lot of, excuse me, nonsense, really big nonsense. So he has a view that we need to defocus, the neurosciences need to focus away from the human brain. Now I am taking these, and this is just a 2 or 3 minute break. It's not just the human brain. We need to de-anthropocentricize our human existence. And Nobel Prize for Physics, was it 1 week ago now, or a few days ago, for science of complexity and the climate. If humans want to exist and live to see the 22nd century, if we are to survive the Holocene and the Anthropocene, we need a new Copernican revolution, which means humans need to come out of the center of the planet. Now, I don't know how many people here know what Sci-Fu is. Mark, I know you do. Sci-Fu are secret meetings at Google. Last Friday, there was a SciFu discussion on bio-reprogramming, life extension, living forever. And you might have read about it. Altos Labs, Yuri Milner is behind this. And myself and I think it was Esther Dyson and a third person asked, can we have a discussion on what are you talking about living forever? Because I mean, biologically, this is starting to be a possibility. And Stu Kauffman emailed me before this meeting last Friday, that he has a gene that extends human life for 10 times. Fine. So I wanted to go, let's have a discussion, please. Where is this living forever going to take place? Like, where are we going to live forever? In outer space? The planet is not hospitable to human life or many kinds of animal life for many more decades. So that's what I went there and I said, listen, guys, what are you talking about? Haven't you noticed? It's like the planet right now is, imagine a pirate ship with made of wood, like one of those boats, and the planet is a boat, and there are people at the front of the boat. There are Silicon Valley, Google, Yuri Milner, living forever, going, yay, we're gonna live forever, and we're gonna artificial intelligence, and the future is beautiful, and we're gonna move to other planets. And they have not looked back to notice that the ship is on fire. Hi, George. I just saw you arrived. You're just in time for approving what I'm going to say next. So I feel there's a disconnect between a very small part of the planet who's talking about living forever, and they've completely disconnected that they don't know that planet Earth is saying, so long, humans. So George, is this okay? If it's not okay, shout, George.
It's fine.
Okay. Right, so this is the message that has been beautifully filmed by George Colburn and Chris Hawes, and where I appear as a core content team, and Stu is behind these. Chris and George have filmed, if you can see here, a beautiful trailer, and the message that we want to say is exactly this. Because I am between physicists, I can say, you know what a Copernican revolution is. You know what happened 5 centuries ago. Physicists were thrown to the fire by saying that the sun was in the center of the solar system and not the Earth. And this is a second. We need one of those, such a revolutionary shift of paradigm. The planet does not exist for the benefit of humans, and we're not going to be alone. We're not going to be here for a long time. Okay, almost finished. I think Georg's not here. So from this biological extending theoretical physics to encompass cosmology and biology, the next project is going to be on the brain. Georg is a person I know that has a large data set. I know clinical brain measurements. He's got multidimensional parameter spaces. Anybody knows more? Somebody who knows more, please email me. And Andrew, my husband, that poor Andrew had to leave because I'm shy and he couldn't come to the meeting. He said, if we want to make a 5 sigma detection on any body of brain data, we need about 2 million people. But of course, you can do more than one measurement per person. So we don't need 2 million people anyway. Right. This is a time in cosmology meeting. If you want to know more about free will, it's all these discussions. This happened in 2016. All these discussions were there. It's opposing the block universe. This is another set of interviews, which is explaining why there's a problem with block universe and free will. It's on University of Cambridge. That's the website. Go and look. I was interviewed for that. And so there's 3 summaries. First one, there's no Lagrangian for biology. There's no standard model for biology. Living systems are constantly reinventing themselves. And in physics, we call this creating new bound systems, new degrees of freedom are appearing, and new elementary particles. And we've started developing tools that quantify and can compare diversity or configuration space in biology with that of the cosmos, dark energy, black holes, whatever. Second summary, determinism. It's way, way old, for crying out loud. It's 7th or 6th centuries before the Common Era. I mean, wake up, this old. We don't need this anymore if we want to make progress in theoretical physics. Reductionism, even worse, 200 to 300 years. Fine, we need to drop it to make more progress. I don't want people coming and saying theoretical physics is coming to an end because we can't see past our methodology. And the last slide is free will. Oh yes, there's nothing but free will. Determinism and reductionism tools do not reach anywhere where any level of complexity where free will is at play. This means the future has not happened yet. It has not happened yet. You're free to do whatever you want. The passage of time is not an illusion, and the future is not written. And welcome to the 21st century. Thank you. Hi, George.
Hello, Marina.
I couldn't see you. Right.
Yeah.
Let me see. Shall I go through the shall I go through the questions? Who wants to? Can you raise your hand?
Yes.
Sauro?
Yes, can you hear me?
Yeah.
Marina, thank you. I mean, there are a lot of fascinating direction here, and I'm not part of this club, but have been kind of initiated by Stu a year ago. Anyway, a couple of comments. Sorry, but when you say there is no Lagrangian for biology, I mean, biology is very dissipative. Obviously, there is no Lagrangian. Maybe you mean Lagrangian as a framework for the sort of theory of everything. That's what you mean.
Yeah. 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 Sorry. I forgot to say. It's like I'm sorry. Yeah, you're completely right. It's just got it. There's a preempt here. So physicists are arrogant. We're arrogant. We think we understand. Everything's physics, and we like to say we understand everything.
And other physics, but by and large, I would agree. Yeah.
Yes. So when I say there's no Lagrangian for biology, it means that I cannot write down with my fundamental physics tools potential energy with scalar fields, and I'm going to derive what a person is going to decide. I
Sure.
cannot integrate the equations of motion to derive what a human or a dog or a cat is going to do. That's what we mean, and you're completely right in your question.
Yeah, if I can, I don't want to take too much time, but the second question is more somehow operational. So you say that you have developed the tools to go beyond, maybe not beyond physics, but I mean to access the biosphere. What are these tools? Is the TAP equation or what else?
Yeah, that's the first tool. It's TAP. And we've derived lots of theorems about how TAP explodes. It turns out that TAP applies not only to the biosphere, but also to the climatic catastrophe that is happening right now. So that's the first tool. It's a very basic, very basic start, a quantification of the configuration space of a living system, and I can talk about it. This is sort of embargoed.
I would be curious to see. I mean, this quantitative.
Yeah. I can put, if Stu was here, I would put everything to him, and he would talk. Let me see here, Sophia. Before aspiring to find the Lagrangian of consciousness or event of the brain, how about aiming lower and aspiring instead to find the Lagrangian of a cell or even of a DNA molecule? Perfect. That's exactly what we've done. We didn't even get, my computer doesn't get to DNA. It only got to RNA 3.5 billion years ago. The RNA world is the one that is currently on the draft. Somebody asked here, a gene that extends life 10 times. Yeah, guys, this is what I mean. This is Silicon Valley. Silicon Valley, that's what the discussions are about. And as soon as I talked to Stu, I said, Stu, we have a movement on the climate. And so tell me what's the latest developments, because I'm going to talk to Silicon Valley and Google, and I'm going to say, listen, you can't be talking about living forever because the climate is not supporting it. And Stu immediately says, no, I have a gene, a patented gene that extends life for 10 times. I believe it. Everybody who knows Stu should believe what is he saying. Does anybody have any questions? Or shall I continue?
Yeah, can I ask a question?
Yes, Roberto. Yes.
I wait before saying too much. I wait to see what your tools are, what these 3 papers say. But just one minor remark, or perhaps not minor. The TAP equation, which seems to be at the heart of your efforts, has no death term. And this
it has.
a major drawback.
Oh, it has. Oh, sorry. Yeah, so I wrote there very, very simplified expression. Oh, the TAP equation. Yeah. No, it's got lots of things. Yeah, it's got extinction, death, difficulty of combination, many.
Yeah, I think it's important to see how, because the form which you showed has only.
It's very simple. Yeah.
It's going to grow hyper exponentially.
Yes. Okay, great. So let's see. Alberto and Paulo and Mark have a question. Alberto?
Yes. Can you hear me?
Yeah. Yes. You're still muted.
Given that you said that you were going to talk about free will, I would like to make a few comments about that, if you don't mind.
Yeah.
So, because you said that, well, determinism, let's say, kills free will, right? So Laplace's demon knows whether or not you will decide to believe in free will. But this is because we I mean, we put quantum mechanics aside. So once you take quantum mechanics into consideration, then the Laplace's demon is a fiction. I mean, because due to the uncertainty principle, you cannot know exactly the position and velocity of all the particles, and therefore, right?
Yeah.
You cannot predict exactly what's going to happen. So my question then is, isn't that impossibility of perfect predictability enough to endow us with free will? So what I mean is,
yeah,
we have incomplete information, so it is then conceivable that we could have acted differently.
Okay, yeah. Like I said, there's a large field of philosophers, neuroscientists that believe quantum mechanics has a role to play in free will. I am not one of them. I would love to see a detection of a correlation and using a clinical clinical data on the brain. I'm not one of those people that believes the works that I have read and seen, and I'm naming no names, have not convinced myself. I don't want to convince anybody that quantum mechanics has a role to play.
Okay, the second thing I wanted to mention is that, because you put this example of the fish and the bacteria, right?
Yes.
That maybe then we should also talk about, well, first, you mentioned about correlations in quantum mechanics, but even if we find these correlations, I mean, correlation doesn't imply causality, which maybe we may need more than that. The thing I was going to say now is that that's a thing that I've been thinking about it, because, I mean, there are many examples there, is that maybe we should also talk about conscious and unconscious decisions when we talk about free will.
Okay,
I mean, for instance, a conscious decision could be just to listen to your talk, right? And an unconscious one could be, for instance, that we have bacteria in our guts, right?
Yeah.
That need certain conditions to reproduce faster. And then imagine that they need more iron, right? Then you go to a restaurant and you think you can order whatever you want in the menu.
Okay, Alberto, yes, right, good. I don't know what consciousness is. I don't know. So I'm not going to touch there. I just work here. I'm just a physicist. That's really, really complex. I leave understanding consciousness for psychiatrists, neuroscientists, preferably non-reductive neuroscientists. And that's what I wanted to do here. As a theoretical physicist, I have zero input to put on what is consciousness. I believe, what I believe is that determinism does not work at the brain level. So arguments that say that we don't have free will because of determinism do not hold. Oh, Paulo. Okay, Paulo's left. Mark, can you go? Hi, Mark.
Yeah, hi. I guess I can remove my hand. I imagined that my basic question is what you're measuring from, what you want to measure from brains or what you would consider a correlation, what you would be correlating together to
Great.
to establish free will. I guess maybe that's in your papers. I guess
no, it's not. No. There's no free will on the papers. There's no brain. The projects I have with Georg are very simple. I am afraid, I'm a bit paranoid at this point of speaking on ideas that are yet not published, because I've been having a hard time. But I can say that my interest in the work with Georg, there are two kinds of communities that I really listen to what they have to say on their studies on the brain. One is the communities of clinical psychiatrists and neuroscientists, so that are actually with their hands on the field. The second community is the community of Eastern Tibetan Buddhists. Really, go to Nepal, go to Tibet, which I have done, spend 6-7 months with these Buddhists, these monks, and just learn in an informal way what experiences they have, their daily life. What do they portray, have to say? So that's, and Georg curiously is interested, says, yes, I suspect a professional accomplished meditator monks have a lot of insight on the brain that we do not. And then now, hi, Chris. Did you want to say something?
Hello.
Hi.
No, I've only just been able to join in, I'm afraid.
Oh, no problem, no problem. George was here to keep the order.
Right,
Marina,
great,
if
thank
I
you.
may.
Paulo,
Okay.
Carrillo?
Hello, Marina. Thank you very much. And I really enjoyed the ideas. And I'm going to ask you something on the conceptual side, since I am from philosophy. I'm talking about the example of the fish in the pond. And it seems to me that you are arguing correctly, in my view, for a kind of strong emergence when you pass from the physical level to
Strong emergence. Yeah.
So this means that a new structure has formed, and that structure has a kind of organization. And this means that some kind of, let's say, creativity, and we are talking about strong emergence, which also means that you don't have kind of restrictions coming from any kind of pre-ordered information. That means that the question is, would you consider that in that case there would be an expression of free will?
No, I don't know what free will is in that case.
Well,
I barely know what free will is in the human case. So I just work here. I'm just a theoretical physicist. Okay. So I try to understand things from first principles, from theoretical physics. Free will, that's high self-organization in the brain, very complex. We're just studying how RNA molecule came to be. The first organism that appeared on Earth, according to some biologists, is the RNA molecule. It's the first time they call it the template synthesis, in which you make accurate copies according to a code, almost like a computer code of molecules. And that is one of the fundamental ingredients for life. So that is, we're theoretical physicists, and we're reaching over to that level of an RNA molecule that is already way beyond what I can do and what I can understand. So free will and the brain, this is for philosophers, for neuroscientists, and with data. Francisco, thanks, Paulo. Let's talk more. Francisco, yes.
Yes, thank you, Marina, for this nice presentation and sharing.
Great,
so to bring people from different communities and fields. Very good. I have actually some comments. I understand. I think I understand the spirit of your talk, and you mentioned the arrow of time and free will, and we know that the arrow of time has at least these three levels: the thermodynamical, the cosmological, and the psychological, and we cannot see these three arrows of time in a separate way. So indeed, we need the different fields like neurosciences, physics, and if we have psychology, also other aspects of beyond psychiatry and neurosciences to study the mind, like you mentioned, to approach these topics. But then you move on to the idea of free will, making a link to biology. And the first comment I make is that it is very easy to fall, so to speak, in reductionism. It is very easy. And to say that free will comes from biology, I would say that we need to be more careful here. We can say that is our best hypothesis. Because if we want to bring together philosophers, eventually even sociologists, people looking at the psychosociology dynamics of human systems, to do statistics and then bring natural fundamental sciences as physics and biology. Then with the concepts we need to be more open, because maybe free will is not only biology. That's a reductionist approach in my point of view. But just if I'm allowed another comment, because then from this link between free will and biology, you continued to the issue of what you were doing and this thing of trying to describe these complex biological systems as the biosphere, for example. And I would again reinforce the idea already mentioned here that, yeah, we have these dissipative systems in biology. So of course it cannot have a Lagrangian nor even a Hamiltonian, because all Hamiltonians are conservative.
Military.
Yeah, conservative systems. And it's good to remember also Ilya Prigogine when he was saying that we need a new approach to dynamics. And he was mentioning we need non-integrable systems.
Yeah.
So eventually mathematical tools can be there and go around determinism, but going also around the idea of only a configuration space and dynamics in a configuration space. So my question for you, very specific question is, besides describing the configuration space of a certain level of complexity of the biosphere, besides that, do you also have a part of dynamics? Or not?
No, this is why Stu would be here. Stu, if I said that we have dynamics, would whap me across the head, would choke me. I don't know, he would kill me. The first rule the Stu wants to say is that what's going to happen next is not pre-statable. So it's because we're physicists with slowly trying to say, okay, Stu, it's not pre-statable, but we can count them. You know, we can regularize infinities in physics. We have experience regularizing infinities. So yes, no dynamics, nothing. It's just, you know, it's first principles going like, we're learning to count 1 + 1 in biology. That there's no dynamics. What Stu really wants, because he wants to end physics, is that nothing is pre-statable. Therefore, we that still use the Newtonian paradigm, integrating equations of motion for each particle, are, you know, beyond retarded, beyond, you know, like 5-century-old scientists trying to use methods that have long been overcome, and so it's a battle. But I am holding strong and saying theoretical physics is not ending. But we have to be, in order to say that we have a common language which is quantitative for the first time, that we can compare something like the configuration space in biology and in theoretical physics, we have to be very careful and very simple. It's just a small step. Of course, we have lots of things coming up, but it was hard enough to enumerate all the reasons why foundational theoretical physics needs to be updated by dropping or incorporating new tools other than our reductive tools. Something which, by the way, I'm saying for the first time, condensed matter Nobel Prizes, Laughlin, Bennet, Anderson, they have known these for years.
Yeah.
Okay, anybody with questions, please? And we are way beyond time as well, I think. I have a question, let me see. Okay, José Ferreira. I'm gonna read one, just this one. I have a question. In the case where free will, whatever you define it to be, is a fundamental part or emergence, it has to be a testing ground for physics, which one day should be compared. How are we to include? Oh gosh, I have no idea. I'm sorry, it's again, as a theoretical physics, I have nothing to offer on free will. I just think that there is free will because the determinism equations do not operate at that level on our brain. So I
Marina,
cannot offer
excuse me,
anything.
could you repeat the question that you were reading?
Oh yeah, I have a question. In the case where free will, whatever you define it to be, either as a fundamental part of the universe or an emergent effect due to the complexity of the system, it has to be a testing ground for physics, which one day should be compared against experiment. How are we to include this arbitrariness in fundamental physics to provide such a behavior? That is the question. I don't believe that there is arbitrariness in free will. I believe that we are agents of our own destiny. Fundamental physics and free will really is like comparing an atom to a galaxy. I don't know how to explain from first principles in fundamental physics why what kind of free will you will have. I just know that theoretical physics does not have the grounds to say there is no free will and the future has already happened. That's my belief. Okay, so is anybody else have a question? Raise your hand right now. Otherwise, I'm gonna end because we're way over time. It's so lovely of IA to host me. I didn't even have a heart attack this time, George, and we weren't taken to the emergency room. And everybody, George, would you like to say something about the project? Or Chris? You're muted.
Sorry, I'm unmuted now.
Let me just say who George is, by the way. George Colburn, he's a journalist, historian who has interviewed all presidents of the United States since Nixon. So pay attention to George.
That's my other life. The science filmmaker in our group is Chris Hawes, who is a partner in this venture with Marina and Stu and others. And I'd like to invite all of you who are interested in this project, which is about to enter liftoff, to send along their email addresses to me, and I can keep them posted. It is the first product that we're developing is a 3-part video series for some kind of distribution in our brave new world. Television, the word seems very old-fashioned now because there are so many options. But if you can remember myname.com, you can be in touch with me via that.
Send them your email. I will send them your email. And is the trailer available? Can they watch the 6-minute trailer, or is better not to yet?
The trailer probably by this time next week, when we open for special guests our website. Okay,
yes,
so the website is about to be finished off, and I would say by this time next week. So anyway, thank you for allowing us a little propaganda here, and very much enjoyed seeing all of you.
Fantastic. Thank you, George. Thank you, Chris, for joining our little group of academics. We really, I really want to say to everybody who's here, you have no idea the quality of the product that George Colburn and Chris Haas put together to help save our planet. Lovely to see you. Thanks for coming, everybody, and have a lovely day and everything.